Welcome to more GibbsCAM videos. In the next month or so, we're going to be going over a lot of 5-axis toolpaths. We're going to kind of focus on that for a while. There are so many things in the 5-axis module that it will take a few months just to get through all of that. Today we're going to do 8 different toolpaths in patterns. So the part I have here is our first pattern, a parallel cuts. And the machine of choice today is going to be a Haas UMC 750 5-axis machine with a BC configuration. So let me open up the 5-axis toolpath here. Process. So first of all, I have my X, Y, Z at the bottom of the fixture here. So if I open up my document page here before we get into the process, I have my stock size and origin here. This just needs to be bigger than your part, and probably you want it a little bit bigger than the fixture. It'll make it easier when you unzoom. And the part offset, I have nothing here, as my X, Y, Z is at the center of this fixture and the center of my actual part, so I don't need to really shift it off here. I have a clearance of 10 inches, which will clear this part pretty easily. So if I open up my process, the first thing I'm going to do is on the Options tab, click on General. Most of these on the pattern cuts will be in General. As you can see, there's quite a few choices down here. And of course, put in your RPM, feeds, and speeds. This particular machine has either a platter or not a platter if it's just a standalone machine, or if it has pallets to go in a pallet changer. I'm not going to do any rotary duplicates. I'm just going to stay on the XY plane on the machining coordinate system here. So the next tab over is going to be my surface paths. So here I'm going to choose surfaces, and we're going to do parallel cuts. So the first thing we need to fill out is this section right here. It says machining angle in XY. And let me show you the toolpath here before we get too far. So this one here is the angle at which you want the cutter to run. So here I have 0, so you can see it's going this direction. If I would have put 90 in there and redo this, to give you an idea, you can see it's going this direction now, 90 degrees. We're just going to stay on 0 degrees. And on the Z, if I click on here, you can see we have 90 here, so that means it's going to go up and over the part. And you can see the different angles here. Of course, you can put anything in between, but this kind of gives you an idea how it's going to go around the part. I just have the drive surfaces at minus 5,000, so you can see the tool actually cut into the part when we render it, so you can see kind of what it looks like. I just have full avoid cuts at exact edges, zigzag toolpath. You can see you can have zigzag, one-way, or spiral. We'll just leave it machining lanes. That's kind of the default there. You have a cut tolerance there. I'll just leave that at a half thou. And I'm just going to do a pretty large step over here just so you can see the toolpath. You can see this is about 1/4 inch spacing here. Now, as far as the tool axis control, we're going to stay at 5-axis. Maximum angle is 3 degrees, and the tool axis will be tilted relative to cutting direction. And we're going to set the side tilt by the angle. Now on here, if I click on here, this is the kind of the lead angle of the tool. If you want to put anything in there, we're going to leave that at 0. And here you can see the pictures here. If this was 90 degrees, it would kind of want to cut at the side of the end mill, and you can see kind of at a 45, and we're going to stay actually at 0 degrees. And we're just going to go orthogonal to cut direction at each position. The gouge check I have on, I just usually do the flute and shaft. I usually don't use the holder front or back, but of course you have those choices as well. And you can do the drive surfaces, and we're just going to leave the check surfaces checked, and retract tool if it has any issues there. Now on the link, you can choose to have lead in, lead out. If I do a lead in, a lead out, and redo the toolpath, you can kind of see the lead in, lead out from here. And you have lots of different choices on lead in, lead out. This is a pretty simple part, but sometimes you have other features that might get in the way of the lead in, lead out, and you can always change that by clicking on the three dots. And you can see you can do a tangential arc. These are the defaults. If you uncheck this, you can see you have a lot of different choices in there. If I did a reverse tangential arc and did a redo, you're going to see how it goes in the opposite direction for the lead in, lead out. You can change either one how you want to. So we'll just use the defaults there. Okay, on the everything else we're leaving the same here. I'm not concerned about gaps or links. We'll do that in other videos. And we're not doing any roughing. And the utility, we're just leaving the defaults here as well. So if I run the toolpath here, we'll first do it as opsim. You can see we're staying pretty much perpendicular to the surface we're cutting. Speed that up a little bit. Now if you want to actually see how the part is going to rotate in space, you click on this little POV lock that stands for point of view, and if you click on that, you can, right now it's set for fixed part. If you click on machine, now you have to have an MDD if you're going to watch the machine, otherwise it won't be showing you exactly what your machine is doing. So if I rewind that, play again, and let's slow it down somewhat again, and you're going to see what the part is going to do in machine space. And even better, we'll go to the actual machine. So if I turn on machine sim, like I mentioned, this machine for this one is going to be the Haas UMC 750. If we slow that down a little bit. And you can see how it's tilting to the one side there. Now this particular machine, you can set limits on the work area limit, so you can see it's staying to the one side here, not rotating the opposite way. But you could change that under the document control if you want to have it go the opposite way, for instance. Let's just look at the work areas there. You can see this is the B+. My graphics, I need to adjust that for this, but you have a B+ and a B-. So if I said on a B-, click on that, and let's rewind it. And you can also look at that under the operation data, so you can change this for each operation to be differently. But you can see I can do B+, B-. So if we have this on B+, rewind it, play again, and you can see it's going the opposite direction. So you can force it to go in the negative direction or the positive direction on the B axis here. Of course, C, we usually leave that unlimited so it can go where it needs to. So that's our first pattern cut called pattern parallel cuts. Our next video here is pattern perpendicular to a curve, and you can see I have a curve here that I've drawn. And let's bring up the operation and the process. You can see the toolpath there. So we're staying perpendicular to the curve, as you can see the curve there. Again, we're on general XY plane. If I go to the surface paths, you can see we're doing surfaces again, same as before, but this time we're doing perpendicular to a curve. And then Gibbs is going to ask you, well, where's the lead curve? So you can see you can click on the lead curve. Click OK. Now I want you to select the drive surface. Of course, we're going to select this top surface there. And again, I'm forcing it into the part so you can see the toolpath there. Everything here is about the same. On the tool axis control, still 5-axis being tilted relative to the cutting direction, angle, and again we're choosing basically 0 on the lead there, and 0 on the tool being 0 degrees to the surface. And again, orthogonal to the cut direction at each position, and we're going to choose there. So if we redo that, you can see the toolpath. And there's our toolpath there. Now, of course, you can adjust the Gauss check, whatever you'd like to do there. A few other things you can do if you want to eliminate these spikes at the end, but it's repositioning on the C and B axis, so it's kind of going to our clearance plane here. You can see on the link here, you can have the retract set to what you'd like here. You can adjust these a little bit more if you want to get closer down. You could also do it on a plane, sphere, or cylinder. I just chose plane on here. And we're not doing any roughing or anything on utility there. So if we do the op sim, and you can see the toolpath perpendicular to the curve. Again, if we go to machine, rewind, and play again. And if we go to actual machine sim, and again, you can tell it you want to cut on the B negative side or the B positive side, whatever you'd like to do. Okay. For the next pattern, we're going to do number 3. This is basically another one, pattern perpendicular to curve as well. Let's open up the process. Everything else here is the same. Surface paths, surfaces perpendicular to curve again, and we of course select the lead angle there, and the drive surfaces. You select that. Make sure you have face selection on so you don't select everything that you don't need. We're just cutting this surface here. Tool axis control, about the same as we did before, but this time we're going to follow surface ISO direction on this one. So we'll redo that one. And again, you could adjust your link in, link out, lead in, lead out. Otherwise, you could leave it off. So if we go to op sim again, and of course we're doing machine, so it's going to pivot the C axis around. There you have it. we go to Machine Sim, now once it cuts the end a little bit, then it's going to start rotating the C. Since this is angled at the first, it doesn't need to rotate C. Turn off geometry. Speed it up a little bit. And there you have your part. This next part we're doing pattern parallel to curve. So you can see my part here. And let's open up the toolpaths here. We have two different toolpaths here. Same tool, 1/2 inch end mill. Click on the Surface Paths tab. This time we're doing parallel to curves. That's two curves. So it says select the edge curves. You can see I have this one selected up here. And I should have actually this one selected down here. And the drive surface is going to be right in here. And everything here is about the same. I'm leaving 10 thou clearance for the finish pass. And again, pretty big cuts here. Tool axis control, 5 axis being tilted relative to cutting direction. The angle, you can see here I have 0 here and 0 here. So we're trying to stay pretty much perpendicular with this surface here. Again, orthogonal to cut direction at each position. Click on here. Gauss check, I don't have this on. You could, of course, check this on, especially if you have some other surfaces that you're worried about cutting into. Link, I'm using lead in, lead out. Roughing, this time we're doing a stock definition. So if I click on here, in the body bag I have my stock, so I click on that. And stock definition parameters, we're going to leave everything here kind of default there. And I'm going to do depth cuts here. So I'm going to say I want to do 4 cuts at 200 thou spacing on here. You can see here, no finish passes on here, and apply it to the whole toolpath. And nothing really changed on the utility. So let's redo that, and then we'll show you the finish pass. So next we have our finish pass here. So again, surface paths, edge curves, drive surfaces, same thing we just did before. Tool axis control, the same here. This time we're doing 90 degrees. And we're going to basically be cutting right to the side of the end mill, which will leave us a lot better finish than cutting with the end of it. Again, orthogonal to cut direction at each position. Gauss check, I don't have any of this on. You can have it on if you'd like. I'm using lead in, lead out again, because I just don't want it to come in and cut down here and leave a witness mark on here. I'm not roughing. Utility, I'm forcing the tool to be a little bit past the bottom lip there by 150 thou, so I'm not just cutting with the tip of the end mill, I'm cutting a little bit past it there. So we go to OpSim. You can see we're cutting with the end. Let's actually put a little color to that. We'll do it by op number. So there's our first roughing pass. Second roughing pass. Speed that up a little bit. And there's our finish pass. Let's get to the finish pass. Let's just put a stop here. Let's say stop before number 2. So we'll speed this up a little bit. That's going to be our roughing. And we'll slow it down for the finish. And you can see we arc in to the part. Going down the step amount we wanted it to do. And our last pass, a little bit below that line, we'll have a nice cleanup. All right, let's do it on machine, so you can see what your machine's actually going to do. There's the roughing and finish pass. And finish pass. Now if we go to machine sim, a little bit better angle there. So there's our roughing. And then our finish pass. So nice smooth toolpath for this. Looks good. So our next toolpath is number 5, pattern morph between 2 curves. So let's open up our operation and process. Operation, I have everything pretty much the same as the other ones here, but on the surface paths, I have selected surfaces, same as before, but this time I have morph between 2 curves. So then Gibbs is asking me, well, where is the first curve? Now, you can usually, if you don't want to extract the geometry off here, you could turn on edge selection, just select the edge. But normally I like to actually extract the geometry off the surface. It makes it a little bit easier for me sometimes, especially if you're going to redo the operation. You have the geometry there and don't have to go back to edge selection. But anyway, click on the first one, and depending on what you select first, it'll either go from the top down or the bottom up. In this case, I'm going from the top as my first one, and I have my arrow going this direction. And the second one, I chose the bottom geometry there, arrow going this direction as well. drive surface. You can turn on edge selection there, face selection, select this edge, and if you want you can right click, go down to select tangent edges, and you can see it selected everything but the top and bottom. This time I'm doing a spiral cut, and we're just going to go step over about 100 thou there. Tool axis control, 5-axis, be tilted relative to cutting direction by the angle and the lead angle. I'm not going to give it any lead angle, but the side tilt angle I'm going to put at 30 degrees here, so it's kind of between the 0 and 90. You can see around 30 degrees there to keep my tool away from the fixture and the vise. Gouge check, I don't have anything on there. If you did notice a tool gouging into something, this is where you would turn that on, and we'll show you more of the gouge check on other 5-axis videos. Link, I'm not using any, don't use any lead in, lead out. It looks pretty good there. We're just going to go right in. If you want to, you could change that to use lead out, use lead in, lead out, and you can use the default values if you want. So on this one, if I use the lead in, it looks pretty good. We can change that as well. But on the use lead out on here, if I change this to, well, if we just redo the toolpath there, let's redo the toolpath there, and we'll change this again to the link. Again, we use the lead in and use lead out. And we'll just leave the default values there. So let's just do a redo. And you can see the lead out gets a little bit, actually it looks like it's actually hitting the vise. So on our lead out, click on here. Instead of using the default value, uncheck that. And let's try a reverse tangential arc just to see what that looks like. Don't forget to click OK. And then let's do redo. And you can see that looks a little bit better. Still getting a little bit close to the vise. Let's try one more there. Let's try maybe vertical tangent arc. Let's see what this gets us here. And that actually looks pretty good there. So we'll stay with that. Nothing in the roughing, nothing in the utility. So let's just render this. So you can see I'm staying about the 30 degrees tilted to keep it away from the vise. And let's run this down to the machine. A little bit better idea of how it's going. Slow it down somewhat. So you can see we're staying away from the vise a little bit better by tilting that 30 degrees. Plus we're cutting more with the edge of the tool instead of the tip. It's always better if you can go off the tip, as the closer you get to the tip you're really not cutting much, and it usually leaves not as good a finish. And our part's done. Now let's look at this in Machine Sim. Okay, let's go down to Machine Sim. This time we're using a DMU65. This is an AC table. You can see why we want the 30-degree angle to keep this away from the pallet. And of course, if you prefer, you could go from the bottom up. especially if you're roughing. That might bring the material a little bit farther on the bull nose, or sorry, the ball end mill up on the side here instead of pushing it. But of course that's totally up to you how you'd like to do that. And with this machine as well, you can do work area limits to keep it always on the front side of there instead of going to the back side. That way it's easier to see, helps to avoid collisions, especially if you can't see it. As we're finishing up there. And there's our arc off. So morph between two curves. Okay, our next one, number 7, is pattern parallel to surface. So you can see we have our part here. And let's bring up the operation and process. So here I have my surface paths. Just a single edge, and we're doing parallel to surface. So my single edge is going to be this edge right here. You can see as you click on the different ones, of course you want face selection on. So this is going to be my single edge surface. And then the drive surface, of course, is what we're going to cut, which is this one here. I'm just cutting into it 3/1000, so you can see the toolpath there, spiral cut. We go to tool axis control. This time we're just doing 3-axis because we're just cutting this surface here. It's just a cylinder, straight cylinder. So some people don't know, in the 5-axis module you can actually choose 3-axis, 4-axis, or 5-axis. We're choosing 3-axis here. You can see the other ones there. Gauss check, I don't have that on. And I don't have link in or out on. Don't use lead in, don't use lead out. Of course you can choose to put those in. Nothing on the roughing. And the utility, I have calculation based on tool center. And one more thing here on the margins, I have add internal tool radius. That'll keep the tool from gouging into this part as well, because it's looking at the tool radius on the tool there. So if we run the OpSim first, as you can see, it's going down and following that pattern, but it, of course it's not going to cut into our surface here. You can see it can only reach down to here because this does not have a radius on there, and you don't want the tool tip hitting the bottom there. And if we go to Machine Sim, same thing there, just 3-axis. And of course if we go to, that was OpSim, if we go to Machine Sim, same thing there, everything's just 3-axis there. We don't need to tilt anything. And there you have this part. So for our last one here is pattern project curve. So we want to project this geometry that we drew down onto the surface. You can see the geometry is just flat, so all you need to do is draw it flat. Let's bring up our operation and process. Surface path. It's going to be surfaces project curves. So it's going to ask you first, where's the projection? So just select all your geometry. Easy way to do that is just hold down the shift key down and you can put a window around all the geometry there. Then of course the drive surface is going to be what you want to engrave onto. be relative to cutting directions, angle, 0 here on the lead in, and this we're going to go again perpendicular, so basically 0 degrees there. Don't have any gouge check on, really don't need any lead in, lead out for engraving, nothing on roughing or utility either. Then on the second toolpath here, let's bring that up. About the same thing here, just some different geometry there. Same tool. I'm just forcing it into the surface by 20 thou, and we're cutting on the center of the tool. So everything else here is about the same here. Now I'm going to separate these, so something new in 23 is we can actually disable some of these operations, so Gibbs actually ignores it altogether. So if I just click on, say, the second one and click on deactivate that, now when we go to OpSim, we'll do it by machine, and you can see we're engraving the large letters. Now if I close that and I go to that same operation and activate it, then go to the first one and deactivate it, we can see this toolpath just by itself. It's a little bit different there. So if we go into Machine Sim, and there we have our engraving. Again, this is on a DMU65 and the other one was on a Haas 5-axis. But you can see fairly easy to program engraving onto a surface. So lots more to come. Thank you for watching.